Welcome. Now let us learn the few definitions that you'll keep on hearing throughout your lifetime. And definitely there are a lot of the definitions of these terms. I'll try to paraphrase in a very simple way so that you understand. First one is statistics. Statistics, by the definition, it is the part of the mathematics. It is one of the branch of mathematics. And it is there for good number of years. If you want a proof, then I have seen one of the university in US that is providing a BSc in statistics for almost 120 years. I have seen the research paper almost many years old, very old. And in my opinion, statistics is there as long as we remember since when we started using the numbers. So it means we know how to take the minimum, maximum, average of the numbers, and that is why I think it is there since when we started using the number, very old. And statistics in the current machine learning, it helps a lot. It helps that the kind of data you are working, what is the population of that? Is it a sample and the population having the similar distribution? Second, if you have built any hypothesis, does that hypothesis still holds with your data? If someone has built some kind of theory, does that holds with your data? How to make sure that the two sample which you have collected, are they from the same population? There is a lot of the things is keep on helping you, and you will see that we'll be using statistics almost every part of the machine learning, and definitely it helps a lot. Okay. Now, second definition, second part is machine learning. Machine learning has been defined again by the very different person in a different way. In my way, I am trying to explain in a very simple way. It is machine learning helps you to do your work a bit better or do the work on behalf of you. So in machine learning, machine helps you to do your work a bit better or do the work on behalf of you. That is what you're trying to teach the machine. This is all about the machine learning. Data science is the science of all of this. And data science itself is, if you see on the right side, it is a science of almost everything, whatever you have heard. And data engineering is a bit different, and data engineering is most about the installation, taking care of data, taking care of compute environment, and so on. So data engineering and data science are the two completely different things. And till 3-4 years ago, I used to see both of these two terms were getting exchanged one for other, but now the maturity has increased and people do not use one for others, but it's good. Data engineering is a different kind of discipline altogether. Now let us learn a very basic concept of linear algebra, and it is useful in the machine learning. So any data point which you say, that will be called a scalar, and any complete column, that is called a vector. Let me show you in an example in an Excel file. So if you see that any data, this cell, this is called a scalar, and the complete column, that is called the vector. And if you say the some rows, some columns, these are called matrix. These three things are important for the machine learning, that is scalar, vector, and matrix. Order 3 onward, those are useful mostly for the deep learning, and these three things you should be aware of it. You will also hear the something operation called vectorized operation. So what is the meaning of vectorized operation? So suppose C equal to A plus B. So what is the meaning of that? It means all the element of A and all the element of B will get summed up in the C. So this will be a C. Here it will be, say, let me show you some example. Say A is say 1, 2, and these are the 3. So C, suppose it is like this plus B. So when I say C equal to A plus B, this is, you write once and all the element will be summed up like this, the formula which you have given. So this is called vectorized operation, and in R almost all the library are vectorized. That means you don't have to run a for loop to go to element by element. They are vectorized. Okay. Now few of the distributions which will be using quite a lot. Normal distribution. Normal distributions, the detail about it, these things you will learn in statistics class. And these are the perfect normal. This is the graph. But in case of machine learning, you may get data like this, which may not be the perfect normal but near to the normal. So this is also good enough. You don't have to worry about it. This is also good. Similarly, in case of uniform, ideally it should have been all uniform, all in a here horizontal. But you'll see that there will be some gap. But this is for machine learning, it is good enough for working, because you will not get the perfect normal in machine learning. There is also you'll get negatively skewed, that left tail long, and positively skewed, right tail long. So these two distribution also you'll get a lot in the machine learning. This is just for information, and when you get that time, I'll explain you that how to deal with this kind of distribution. Plus, what is the meaning of distribution, that you will be learning in statistics class. And few of the types of data and variables. So let's start with a very simple one. Numeric data, all of us know. Numeric can be classified into the two, continuous and discrete. Continuous itself we can say ratio. Ratio, if you know that, many things we start talking about ratio. So if one class has a, say 50 male student and 25 female student, then we say that in this class the ratio of male to female student is 2:1. If a fruit basket is having, say, 10 apple and 2 orange, then we can say in this fruit basket the ratio from apple to orange is 5:1. That is what we keep on saying it, and this is mostly used. This is mostly used for taking the ratio, speaking in that term. And interval. Interval, basically it is a kind of range. So it is having the range. What it means, that if you see that it is said that in case of for this subject the maximum marks can be 100. So it is said 0 to 100. That is the range. It means you can get any number between this. That is the numeric thing. Discrete. This discrete is the count, like say number 1, 2, 3, 4, 5. And discrete is the number of students taking this course, number of students in the class, number of employee, and so on. The other data type is categorical, where each data type is classified. So what it means, let's assume that we are talking about four-wheeler. So four-wheeler could be car or say jeep, and if you also include different types of four-wheeler, that may be another. So this is become the type. That is what, and all this type you cannot compare. You cannot say car is better than jeep is better than car, nothing like that. Although you can compare attribute. It may happen that car is giving you more comfort rather than jeep. Plus, if you talk about that, it may have the say Mercedes may be more costly than a normal car. That can be compared, but overall car and jeep cannot be compared. That is what it's nominal. That is nominal. And ordinal data type is where there is order, and the order is there in many things. If you see the one of the very known example, Likert scale. Likert scale, when you have participated in any survey, that there are highly unhappy, neutral, happy, and very happy. That is the Likert scale, and all of you have participated in one or other survey. You must have observed this. So this ordinal, that is the data, this Likert scale. Dichotomous is the special data type where only there are two types, 0 and 1. That is why it's called dichotomous. Since this course is machine learning, so we'll keep on hearing about the independent variable. Independent variables are some places you'll also see experimental or predicator. So these are the data captured independently, and those are the useful for deriving or finding out the dependent, that is the outcome. You'll keep on hearing independent variable and dependent variable a lot. This is some of the metrics of what you can do with the different types of data and what you cannot do, and these are useful if you have any time you're not sure that the data which you have, what can you do, basically what can you do and what you cannot do. So that is what you can come to this one and see what you can do and what you cannot do. Okay, so that's all for this video. Thanks for watching it. See you in the next one.